Earthquakes are natural phenomena that occur when there is a sudden release of energy in the Earth's crust, causing the ground to shake. They can have devastating effects on human populations and infrastructure. Here's an overview of the science behind earthquakes, including their causes, effects, and prevention measures. Causes of earthquakes: tectonic plate movements. The primary cause of most earthquakes is the movement of tectonic plates. The Earth's lithosphere, outer layer, is divided into several large plates that float on the semi-fluid asthenosphere beneath. When these plates interact at plate boundaries, such as convergent, divergent, or transform boundaries, stress and pressure build up, eventually leading to an earthquake. Faults. Earthquakes commonly occur along faults, which are fractures in the Earth's crust. The two main types of faults are strike-slip faults, where plates slide past each other horizontally, and dip-slip faults, where plates move vertically. Effects of earthquakes. Ground shaking. The primary effect of an earthquake is the shaking of the ground. The intensity of shaking depends on factors such as the magnitude of the earthquake, distance from the epicenter, and local geology. Severe shaking can cause buildings and infrastructure to collapse, leading to loss of life and property damage. Surface rupture. In some cases, earthquakes can cause the ground to rupture along the fault line, resulting in visible cracks and displacement of the Earth's surface. Tsunamis. Underwater earthquakes, particularly those occurring near subduction zones, can trigger tsunamis. These large ocean waves can travel long distances and cause significant coastal damage when they reach the shore. Aftershocks. Aftershocks are smaller earthquakes that occur in the vicinity of the main earthquake. They can continue for hours, days, or even months after the initial event, further damaging weakened structures and hindering recovery efforts. Prevention and mitigation. Seismic monitoring. Scientists use seismometers to detect and monitor seismic activity, helping to understand earthquake patterns, predict aftershocks, and issue early warning systems. This information can be used for emergency preparedness and evacuation planning. Building codes and engineering. Implementing and enforcing stringent building codes with earthquake-resistant design principles is crucial in earthquake-prone regions. This includes techniques like base isolation, separating the building from the ground, and structural damping, reducing the building's response to shaking. Land use planning. Understanding seismic hazards and incorporating them into land use planning can help prevent the construction of critical infrastructure or densely populated areas in high-risk zones. Public awareness and education. Educating communities about earthquake preparedness, including proper response during an earthquake and how to secure buildings and objects, can save lives and minimize injuries. Retrofitting. Strengthening existing structures to withstand earthquakes through retrofitting techniques can significantly reduce damage. This involves reinforcing buildings and infrastructure with materials like steel and adding bracing or shear walls. While it is not possible to prevent earthquakes entirely, these measures can help mitigate their impact and improve the safety and resilience of communities in earthquake-prone regions. It's important to note that the science behind earthquakes is complex, and ongoing research and technological advancements contribute to our understanding of these phenomena and the development of more effective prevention and mitigation strategies.